Okay, let's go back to n equals 0 to infinity n factorial xn. So here un is n factorial xn, and un plus 1 over un is n plus 1 factorial xn plus 1 over n factorial xn. And that simplify, we know the n plus 1 factorial over n factorial is n plus 1. And xn plus 1 over xn is x. There. So now we want the limit as n goes to infinity of un plus 1 over un. And that is the lim as n goes to infinity of n plus 1 x. Now look, x is fixed for some fixed value we're looking for. And n plus 1 as n goes to infinity, so this is going to go to infinity. So by the ratio test, that diverges. So by the limit ratio test, n factorial xn diverges for all x. So here, the radius of convergence is 0. That means there is no radius of convergence. It's empty. Okay? No radius of convergence. All right, so here's an example of a series that diverges for all x. All right? So let's try another one. Let's try another one. And this is going to be n equal 1 to infinity x minus 3 cubed over n. Okay? The same thing we do. We will let un is x minus 3 to the n over n. And then look at un plus 1 over un, that is x minus 3 n plus 1 over n plus 1 times n over x minus 3 to power n, and all that in absolute value. And you will see this is equal to n over n plus 1 times x minus 3. So this is n over n plus 1 times x minus 3. You see that? Because n over n plus 1 is always positive. So now we look at the limit as n goes to infinity of un plus 1 over un. And that is the lim as n goes to infinity of n over n plus 1 x minus 3. Remember, x minus 3 is some value fixed. So this is going to be x minus 3 times n equal to 1, n over n plus 1. And we know that limit is 1. So this is x minus 3 times 1. So this is x minus 3. And we want this to be less than 1. Remember, the ratio test tells you the ratio at infinity in absolute value has to be less than 1. So we have to force it to be less than 1. Okay, so here r is 1. Now, we need to look at the endpoint. We need to look for the endpoint. Okay. So must check the endpoint. So we know, so we have convergence for x minus 3 between 1 and minus 1. So we need to check minus 1 equal x minus 3 and x minus 3 equal 1. Is that clear? That's what we need to check. Because we don't know at equal, less or equal. Remember, because the ratio test tells us if this is equal to 1, then the ratio test is inconclusive. So this is what we are trying to do. So we're trying to make sure we set it equal to 1. Okay. So that's most likely is going to be the alternating series test every time you have something like that. So for x minus 3 equal minus 1 or x equal to 2, we plug in here. So we'll have n equal 1 to infinity 2 minus 3 cubed over n, right? And what do we have? N equal 1 to infinity minus 1 cube over n. And that is minus 1 over n, which diverges. We know that, right? And now for x minus 3 equal 1, mean x equal 4, so this here becomes n equal 1 to infinity, put 4. You'll have 1 cube over n. This is 1 over n, so that diverges again. Okay, so what do we know? So we know that this series only converges for, so we concluded the series or power series diverges at the endpoint. Minus 1 and 1. So the convergence is for x minus 3 less than 1, or minus 1 less than x minus 3 less than 1, or minus 1 minus 3 less than x less than 1. I'm adding 3. Minus 1 plus 3 less than 1 plus 3, or 2 less than x less than 4. So these are the value for which this series will converge. Okay? Any questions? Any questions? All right. Did I simplify this wrong? I will have to look at it again. Okay. All right, so now, oh, it's okay. One more example. Okay. Let us try n equals 0 to infinity minus 1 to the n, x to the n over 2 to power 2n times n factorial squared. Okay? So this is a little bit complicated, but it is doable, of course. So let's, so here un is minus 1 to power n, x to the 2n over 2 to power 2n times n1 factorial squared, and un plus 1 is minus 1 n plus 1 x 2 times n plus 1 over 2 to power 2 n plus 1 n plus 1 factorial quantity squared. Okay? So, and I'm going to look at un plus 1 over un. That is minus 1 to the n plus 1 x to power 2 n plus 1, okay, over 2 to power 2 n plus 1 times n plus 1 factorial square, and I'm gonna flip, will be 2 to power 2n n factorial square over minus 1 to the n x to the n. So you see all that? Now, this is a positive, so they're not gonna make any difference. It's always 1. So we're gonna have, let's try to simplify. We're gonna have x 2n times x squared over x to n. So I took this one with this one here and this one, okay? And this is gonna be 2 to power 2n times n factorial square over 2 to power 2n times 2 squared, okay? So now I'm taking this one here, 2 to power times 2 squared times n plus 1 factorial square. It's a little bit complicated. You need to sit down with a piece of paper and work all the details out. So you will see this over this go away. So I'm gonna have x squared. Now this one with this one go away. Over 2 to power 2. And n factorial, this is gonna be n factorial over n plus 1 factorial squared. And we already know what this is. So this is gonna be x squared over 4 times 1 over n plus 1 squared. You see all that? So this is what you're gonna end up with. Okay, so now, again, there's a lot of simplification here you need to carry out, and very, very carefully. Okay, so when you sit down and read your note and watch the video, please have pencil and paper and write things down, the details. Okay, so now, if I take a look at the limit, so the limit as n goes to infinity, un plus 1 over un, if the limit as n goes to infinity of x squared over 4 times n plus 1 squared, guess what? That is 0. So this series, this limit is always less than 1. So regardless of what x, so regardless what x is, the power series always converge. Thus, here r is infinity, because r, the radius is so big to include all the real numbers for which this power series converge. Okay, so this is it. You need to do a lot of examples. Now let me assign you some homework problems. Stay with me. Okay, so it's gonna be page 633, number 1 through 31 odds. Okay. And 41, 43. Okay? And we will keep going next time. So email me if you have any questions about your exam. I will email it to you as an attachment, put it on Dropbox, and I'll do that at 10 o'clock. You return it to me by 4 o'clock. Have a good day. Thank you very much.